Today we will discuss about uh, estimation of mean precipitation by the Thiessen Polygon Method. You know, when rainfall is measured by gauge station, which are known as rain gauge station. Now, in an watershed, which is a very large area, when a watershed is there, suppose we want to know the mean precipitation of this entire watershed. Let us represent it by P subscript M. And sorry, you have in total n number of rain gauge stations which measure the rainfall at that station. Now, how to find the mean precipitation? Now, there are three methods for it. One is the arithmetic mean method, one is the Thiessen mean method, another one is the isohyetal method. In this presentation, I will discuss about Thiessen mean method. So what is that? Now suppose you have a watershed where there is three rain gauge stations. Okay, let it be P1, P2, P3. So to find the mean precipitation of this watershed by the Thiessen mean method or Thiessen polygon method, you have to apply this procedure. First of all, connect the adjacent rain gauge station with a straight line. Okay, let it be this is P1, P2, P2, P3, P1. Now bisect this line by drawing a perpendicular. Bisect these connecting lines by drawing a perpendicular. Okay. Now, what you can see is that if I draw this perpendicular after bisecting the connecting line until the end of the watershed boundary, then you see surrounding the rain gauge station P2, this rain gauge station is surrounded by a polygon. So the polygon is like this, correct? Let it be more clear. Now this is the bisect. This line is extended until the boundary of the watershed. So you see that this polygon P2 is bounded by this polygon, right? The bisector of P1 and P2 and the bisector of P2 and P3, these two bisector, when extended up to the watershed boundary, it surrounds the rain gauge station P2. Similarly for P1, the bisector of P1 P3 and the bisector of P1 P2, when extended up to the watershed boundary, it creates a polygon, okay, and that polygon surrounds the P1. And same for P3, the bisector of P1 P3 or P3 P1, whatever way you can say it, and the bisector of P2 P3. Okay, this again engulfs the or surrounds the rain gauge station P3. Now you can say that these two lines is clear of the polygon, but what about this line? This is just like a curve. Now as you know that we can represent the curve by a straight line. We can assume that. So let us assume that from this point M to this point N, if I draw a straight line, then you can see a triangle is surrounding the rain gauge station P2. Similarly, for this, here we have to draw a polygon, and from M to O, and from O to, let it be X. This is creating a polygon, and you can represent it as a trapezoid. Okay, you can represent it as a trapezoid. Okay, not exactly a trapezoid, but you can assume it as a trapezoid. So this is a triangle, this is a trapezoid, and for the rain gauge station P3, again you can draw here one curve, here one curve, and this is also another polygon. If I draw from X to Y and from N to Y, so you can assume a polygon here also. So these three polygons, number 1, number 2 and number 3, actually surrounds the rain gauge station P1, which is situated here, P2, which is situated here, and P3, which is situated here. Now the formula of estimating PM, that is mean precipitation of the watershed, by the Thiessen mean method is like this: P1 multiplied by A1. A1 means the area of the polygon which surrounds the rain gauge station P1, plus P2 multiplied by A2. A2 is the area which surrounds the area of the polygon which surrounds the rain gauge station 2, that is P2, and P3 multiplied by A3, that means P3 is the rain gauge station 3, and this is the polygon which surrounds the rain gauge station P3. So that area is A3, so P3 into A3. So area of this polygon which surrounds the rain gauge station P1 is A1. Area of this polygon A2, it surrounds the rain gauge station P2, and this is the area of A3 which surrounds the rain gauge station P3. So it states, to estimate mean precipitation of this watershed by Thiessen mean method, it is P1 into A1, P2 into A2, and P3 into A3 divided by A1 plus A2 plus A3. Okay, this is the formula for estimating the mean precipitation by the Thiessen mean method, or it is also known as Thiessen Polygon Method. Okay, so now let us take an example and try to solve that problem. You see, here is it. This is the formula. A1 P1 plus A2 P2 plus A3 P3. If there are n number of rain gauge stations in that watershed, then you go up to An into Pn divided by the summation of the area surrounded by the polygons. A1 means the area which surrounds the rain gauge station 1, A2 means the area which surrounds the rain gauge station 2, A3 means the area which surrounds the rain gauge station 3, and so on, up to A. Now, we will take a real life problem and then try to solve it by the Thiessen method. Okay, so the problem is like this. So the problem is you have to estimate mean precipitation of a watershed when there are 4 number of rain gauges and for a certain day the precipitation measured by rain gauge 1 is P1, which is equals to 10 millimeter. In that same day, the rainfall measured by gauge station 2 is P2, which is 5 millimeter. Similarly, same day rainfall as measured by G3, 7 millimeter, and ultimately G4, 6 millimeter. Same day rainfall. So if you want to find out the mean precipitation of that same day with the help of Thiessen Polygon Method, then what we have to do is, suppose the location of gauge stations is like this: G1, G2, G4. So this is the location of gauge stations. Our first step will be to connect with the help of a straight line G1 and G2, G2 and G3, G3 and G4, and G4 and G1. Now if I know what is the distance between this G1 and G2, or the length of this line, this interconnected line, suppose this is 7 kilometer, this is 6 kilometer, let that be, this also is 7 kilometer and this also 6 kilometer. So what we do is, we take a central point and draw a perpendicular bisector upon each of the interconnected line. That means from the center point C, we will draw a perpendicular bisector sorry, upon the interconnected line G1, G2. Similarly, a perpendicular bisector is drawn upon G2, G3, then G3, G4, then G1, G4. Correct. So little bit. Okay. So as this is a perpendicular bisector, so this will be 3.5, this will be 3.5, because the total length is 7 km. For G2, G3, this will be 3, this will be 3. For G3, G4, this will be 3.5, this will be 3.5. And similarly, this will be 3 km, 3 km. Correct, as this is a perpendicular bisector. Now, what you have to do is, you have to find the area of all these polygons That means you have to find the area of this polygon which is connected to or which surrounds G1. Then you have to find the area of this one. This will be your another polygon. And this is your, this is your another polygon. Now this polygon, which is actually a rectangle, as we can see that this is 3 km, this is 3 km, as it is perpendicular, this is parallel, so 3 km, 3 km, 3.5, 3.5. So this is a rectangle. So this area is connected to G1 or it is surrounding the G1. So let it be A1. Let this area be A1. And let this area, as it is connected to or surrounding G2, this will be A2. Similarly, this will be A3 and this will be A4. Okay. So to find the mean precipitation of that watershed, PM, what you have to do is you have to multiply the area A1 with the precipitation of that area. That means G1 has measured precipitation P1. So you have to multiply this P1 with the area A1, as A1 is connected to G1. Similarly, A2 multiplied by P2, A3 multiplied by P3, P4. This will be divided by the total area of the watershed. That means this entire rectangle. So it is given by this A1, A2, A3 plus A4. Basically, it is the total area of the watershed. So now our next step will be to find A1, A2, A3, A4. Now A1, you see this is the rectangle, and as is the formula of rectangle, it is A by A into B. So if this is A, this is B, you have to multiply A into B. Correct? Correct. So this is A into B. So area 1, A1 will be A into B. That means this is 3 km, because this 6 km interconnected line is divided into two equal length line, as it is a perpendicular bisector. So this is 3 km and this is 3.5 km. So you multiply 3 with 3.5 and you will get so 3 multiplied by 3.5. So it is 10.5 square foot. Similarly for A2, it will be 3 into 3.5. So this will also be 10.5 square km. A3 So this will be 3 into 3.5, same 10.5. A4 will also be 10.5. As this is a rectangular watershed and you are bisecting its sides, so it will create 4 different rectangles within the uh, original rectangle. So as you have found, A1 is 10.5, A2 is 10. All A1, A2, A3, A4 is 10.5. So now what you will do, A1 is 10.5, multiply with the P1. P1 is 10 plus 10.5, multiply with what, P2, 5. So, and again plus 10.5 into this one, 7 millimeter. Now note that these are all in millimeters, but this is in kilometers, correct? So plus your P4, this one. So 10.5, and this will be 6 millimeter. Now as this 10.5 is equal, A1 to A4 all is 10.5. So take 10.5 common, and then what happens? These are all in equal unit, 10 mm, 5 mm, 7 mm, 6 mm. So 15, 20 to 28. So you can say this as 10.5 we multiplied by 28, correct? 10 plus 15 plus 7 means 22, 28. But this is in millimeter, so you have to bring it into kilometer so that it yield or it result into volume. But as you know, we are trying to find this mean precipitation. So what we do is, that is why this the what we will do is 10.5 squared again multiplied by 28 millimeter. Now I think we have forgotten about that division by the total area of watershed, this part, correct? So what is this word? This is actually 10.5 plus 10.5 plus 10.5 plus 10.5, that means 4 into 10.5. So what is it coming? It is coming as 4 into 10.5. This is 42 square kilometers. So this is your 42 square kilometers, correct? Now you see square kilometer get deducted. What remains is the millimeter, which is the unit of precipitation, or rather mean precipitation. Now, so we have what? We have 10.5 multiplied by 28 millimeter divided by 42. These two terms are unitless because square came, square m deduct out. So let us see what happens. Let us divide 10.5 by 42 first, as they are both unitless. 10.5 divided by 42. 10.5 divided by 42 is 0.25. Now you multiply it to 28. So 0.25, you multiply it to 28, it is coming as 7 millimeter. I hope you have understood. 10.5 divided by 42, as these are both are of same unit, and also we have deducted out the units. So these two are multiplied, divided first. 10.5 divided by 42 will be 0.25, because as you know, each of these area is 1/4 of the total area of, in this case, in this rectangular watershed. So 0.25, that means 25% of 28 millimeter will be 7 millimeter. So the answer will be 7 millimeter. Average precipitation of this watershed is 7 millimeter as per the Thiessen Polygon Method. So with this, we stop this tutorial. I think you have understood what is TPM. Remember this, the area of watershed varies with problem. So, but the procedure, the basic procedure is same. You have to connect the gauge station, adjacent gauge stations with a straight line, and then you have to divide it into equal parts by a perpendicular bisector. And then according to the shape of the polygon, you have to apply the area formula and use this equation that I have discussed, this equation. This equation Pm, that means mean precipitation equals to A1 into P1 plus A2 into P2 plus A3 into P3 plus A4 into P4 divided by total area. And this will give you the average precipitation of the watershed. With this, we conclude this tutorial.